B on 4.2. Okay, so it says on the sketch of e to the x, well, e to the x will look something, it's a exponential, so it goes through 1 and increases, something like that. So at 1, it'll be at e, which is 2.7. So get it a little bit better looking there. An exponential e to the x looks something like that. And it says go from 0 to 1. And we're supposed to find the area under the curve. We're going to estimate it by doing left Riemann sums, 2 of them. So I'm going to go up on the left side and go over halfway, and then left there and go over halfway. There's the 2. You can see that that sum will be an, the left will be an underestimate, and these will be the sum of, well, we have to get the height here, which is on the left side, it's 1, because e to the 0 is 1. So it's 1 times the width of a half, plus, now the second one is going to be, the height will be e to the 1/2, which is the square root of e, times the width, which is 1/2. And I can work those out. That's what those would be. Now, if I did right-hand sums, then I have to go to the curve on the right-hand side and draw it, and then on the right-hand side and draw it. So you can see that the right-hand side is going to be overestimates. The overestimate is the right-hand one. And we would have to go the height at e to the 1/2 times the width of a half, plus out here, which is e to the 1, or just e times 1/2. And that's how we do that problem. Number 4, why we have a graph of 3x plus 4. So I'm going to make a graph of that. So let's just go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4, 6, 8, 10, and we'll do 1, 2, 3, 4, 5. And we're supposed to do this between 2 and 5, find the area under this curve. The curve starts at 4 to 4, and it has a slope of 3, so it goes up 3 by 1, goes up 3 more, that'd be 10 by 2, and by 3 it'll be at 13, and by 4 it'll be at not 13 but 16, and by 5 it will be 19. Okay? And it says do M4 between 2, oh, this is the line. And M4 means we have to divide the width of this, which is 5 minus 2, into 4 sections. So each one will be 3/4. Okay. So we're starting at 2. So let's just label these. We got 2, then 3/4 more than 2 is 2 3/4. Then 3/4 more than 2 3/4 is 3 1/2. And then 3/4 more than that is 4 1/4. And 3/4 more than that is 5. And that works out. So that's 2 3/4, 3 1/2, 4 1/4, and then 5. Okay, so if we're doing midpoints, then we have to go at 2 3/4, go to the curve, which is about there, and draw our rectangle. Then we go halfway and draw our rectangle. Halfway and draw our rectangle. Oh, nope, I didn't do it at the 3/4, so that would be here. So halfway is about there. 3 1/2, which should be halfway, be about there. Didn't get enough of them in here. Halfway be about there. And there. So what is the midpoint? Well, the width of the intervals, the width of each rectangle is 3/4. And if I have to go halfway into them, that would be half of 3/4 or 3/8. So halfway between these two is 2 3/8. 3/8 more than 2. Then I have to go 3/8 more than 2 3/4, or 3/8 less than 3. That's 3 1/2, which is 3 1/8. Then I got to go 3/8 more from this one, or less than that one. That would make it at 3 7/8. And then 3/8 more or less, and that would make it 4 5/8. So I got to figure out the height at each of these places, which means I got to plug this into the 3x plus 4 equation. This one, this one, this one, this one. Then each one of those will be times a width of 3/4. So it'll look like 3/4 parentheses 3 times 2 3/8 plus 4. That's the first one. Plus 3 times 3 1/8 plus 4. That's the second one. Plus 3 times 3 7/8 plus 4. That's the third one. Plus 3 times 4 1/4. No, 4 5/8 plus 4. That's the last one. Okay? Now I'm going to do that on the calculator. I'm going to go clear this. I'm going to go to my stat, edit, and I'm going to go to list 1, and I'm going to type each one of those in. And clear list 2. List 1, I'm going to type in 2 3/8. 2 plus 3 divided by 8. 3 plus 1/8. 3 plus 1 divided by 8. 3 plus 7 divided by 8. And 4 plus 5 divided by 8. 4 plus 5 divided by 8. There's my 4 places, and I want to use, I got to find the function of those places. So I'm just going to go over here in list 2, and I'm going to type in, I want to do, the equation was 3x plus 4. My x's are in list 1, so I'm going to write 3 times list 1. List 1 again is down here above 1. 3 times list 1 plus 4, and that calculated these plugged into the equation. Then I want to add those up and take them times 3/4. So to add those up, I'm going to quit this screen, go to second list, go to math, and ask it to add up the numbers in list 2, and it tells me that's 58. So 58 times 3/4 times 3 divided by 4 is 43 1/2. finally got the answer to that one. Okay. Okay, now, my rectangle's gone. I don't know what's going on here. Okay, hopefully this is still working. Use a similar geometric formula to find the exact, a familiar formula. Well, this is a trapezoid. The width is 3. 2 to 5 is 3. And the height, for a trapezoid, use the average. And this side it's 10. This side is 19. So we go 10 plus 19 divided by 2 to get the average height. So that's 29 divided by 2 is 14.5 times 3. 14.5 times 3 is 43.5. Same answer. And why do we get the same answer? Are they the same? Well, the amount that this one's over is also how much it's exactly under. Same here, and same here, and same here. So when it's a straight line, the midpoint is going to give you the exact value. It will not happen on list L4, left 4, or right 4 Riemann sums, because the lefts will be all under and the rights will be all over, but the M will be right on, even if you did M1, which is what doing this was. Okay? And describe the collection of functions for which the case that the m's will always give the exact area. Well, that will happen on any linear function, any straight line function. Okay, I'm going to stop there.